Hi everyone, I'm Liam Kavanagh. I'm a program manager with the Azure Search team. And for those of you that were expecting a lad today, I apologize, you're not going to get his amazing accent. I will try to do my best. I'll try to bring out a little bit of my Canadian accent, so hopefully that will suffice. But today I really wanted to talk to you a little bit about knowledge mining. And what we're doing within the Azure Search team is we're starting to leverage artificial intelligence into the process of ingestion so that we can do a better job of understanding your data, putting structure to it, and then allow you to have that really strong search experience over it. So for those of you that aren't familiar with Azure Search is one of our platform as a service technologies. It's been available and generally available for many years now. And the goal of Azure Search has always been to make it easy for developers to build a great search experience over your data. So that's a really important distinguishing factor, is that it's over your data. And as you can see from all of the different features here, there's a lot of capabilities built into the system to make it easy for you to do. All those things you would expect, whether it's type ahead search, faceting so you can drill down on the categories, geospatial search, synonyms so we understand variations, deep understanding of languages, so it doesn't matter if it's English or German or other different languages, we can really effectively provide that search experience. Now, if you look at traditionally, what most customers have built using Azure Search is experiences over your content that I would say is much more structured. If you think about structure, usually this data might be coming from a database, it might be coming from a NoSQL store, but it has structure to it, it has fields to it. And that's really important from a search experience because the more structure you have, the better experience you can offer. It's not just searching for words, but it's allowing you to categorize that content so that you can drill down into it and find effectively what you want. So it doesn't matter if it's something like AutoTrader where it's used car listings, or Real Madrid where you're allowing the players to search through game statistics and data, or JLL for real estate. There's typically a very defined structure. But if you look at it, not every piece of data is like this. This is actually a real customer of ours. This is their data. You know, it's all kinds of different content sitting in files and folders and books that they periodically need to look at. It doesn't matter if this is a medical content or legal content. People need to come in to these rooms and find what they're looking for. So how do you handle that? Or more specifically, take the fact that there's 80% of all business content is unstructured. How do you put structure to it? And that's what I want to talk with you today, is how we can help you understand that content, put structure to it, leveraging artificial intelligence so that you can build out a really effective search experience. So I have a couple of different examples here that we can kind of talk through. If you think of unstructured content, it could be coming in PDFs, and PDFs get complicated because it's not only text, there could be some images embedded within that. Word documents, HTML files, TIFF files, maybe it's facts and scans, pure images, forms, all kinds of different content that you as a developer probably want to let your users effectively search over. So here's an example of an image. This one actually came from a JFK data set, and I'll actually show you a demo of that in a second. But this is a PDF, and it actually has embedded within it a TIFF, an image within it, so that it's get very complicated to just search for those words, because you have to do OCR, as Kelly was explaining a little bit earlier, to understand that and be able to drill into it. Or let's take an example of this picture. This is Scott Guthrie, our Senior Vice President for our organization. If you look at this picture, there's a lot of interesting pieces of data if you understand it. You can understand that he is, his name, Scott Guthrie, Executive Vice President. You can see that he works for Microsoft, interesting data. Maybe the fact that his shirt, not as traditional red, but maybe a blue color. All this data is useful for a search engine to be able to drill into. Now, as we've been talking throughout the day, what we're doing is we're integrating into the search process a number of cognitive services. And I go through a couple of examples in a few minutes, but it's really important to note the tight integration of these technologies so that we can look at your content as it's coming into the search engine, understand it, get meaning to it, put structure to it, and then allow you to build that search experience over it. And I'm going to show you a couple examples. So let me just go over to this page here, and I won't spend too much time because hopefully some of you saw the presentation that Kelly just did. But for those of you that didn't, I'm going to show a couple of the cognitive services that we're going to be walking through today. We're going to look at what's called the computer vision. And if you go to the computer vision page, you'll notice there's a couple of interesting things. You probably saw this before, where if you look at it in an image, it can detect a number of items from that. For example, train, people, walking, other aspects about that image. If you look down here, it's doing OCR so that it looks at that image and extracts out the words from it, which can then be full text searched. If you look at something like this, handwriting, this is another image perhaps that we need to be able to extract text for. And this is really hard because we need to understand the various different types of handwriting that come into play. And I recommend, if you didn't get a chance to see the session before, Kelly did a great job of walking through some of those aspects of OCR. The other thing that I find to be really effective in this part is what's called text analytics. So this is where you can supply a set of text, and we go through it and we try to understand interesting aspects of it. For example, if you look down here, we have this sentence here, and you'll notice a couple of things we found. We identified that it was English text. So if you're ingesting data, you might want to understand if it's English, Spanish, German, or some other piece of data. Some key phrases. These are important words or terms or phrases that were found in your content. So this has been trained very effectively to be able to identify important words. The sentiment. Was it a positive sentiment, a negative sentiment? Once again, this can be used for filtering so that you can narrow down results. Some linked entities. Like for example, you'll notice that it was actually we identified the word Seattle and Space Needle. Very important entities that you can then define. And then on top of that, within Azure Search, we also do what's called named entity recognition. So we can actually identify people, organizations, and locations so that you can build out that experience over it. So now what I wanted to do is show you a quick demo of what we can build using this type of a capability. And I'm not going to spend too much time on this, but I do want to show some of the aspects of it. For those of you that haven't seen this demonstration before, this is a search implementation over a set of data that the US government provided. As many of you probably are aware, during the after the JFK assassination, there was a lot of analysis and research and investigations that happened. So what happened was there's a lot of content that came about from this. And so the US government initially released some data. Earlier this year, they released some more, but this was in a PDF format. It was very hard to understand what was in that content. So not only was it in a PDF, but often they were images of documents that were embedded into that PDF. So really, really hard. Not something you could just search as is. So we thought it would be interesting to take that content and then actually try to build out a search experience over it. So I'm going to go through a couple of things to just kind of give you an idea of what you can accomplish once you have this structure. So what I'm going to start with is this search term Oswald. Many people believe that Oswald was the person behind the assassination. So I'm going to search for that because, as you can imagine, there is probably a lot of, oops, let me just put the name here and search for that. Here we go. And you'll see, as from the search results, a couple of interesting things. Even though we just had that PDF with the images within it, and you can actually see within here, a lot of these cases, the content was not very easy to read. Not only was it text, there's often handwriting. For example, here, how you can see we highlighted the word, we use hit highlighting, a search engine capability, to find the word Oswald in here. I can even go down here, and we used Kelly's Vision APIs to identify that this was a picture of Oswald. That was metadata that we could use from the search perspective. So when I search for Oswald, it finds it. You wouldn't know that unless we had actually identified and understood that content. You can even go down and you can see that it gets really hard. Sometimes it's a combination of text and handwriting all combined within it, and many other things. Here we actually did what's called cryptonym analysis, where we actually built a custom skill as part of the AI that looked at the words and identified aliases that were used. And this was actually an alias for Oswald, which we could then do. We could find redaction, etc. But the thing that I really want to highlight from this side is the idea of tags. Remember when I was just showing you the text analytics, where we put in that text and it identified a set of key phrases? That is exactly what we're leveraging here on this left sidebar, where we search for Oswald and we can see, using the search engine, here are the set of key phrases that are often highly correlated with those documents. So it allows me to use the search engine to say, you know what, that's really interesting. I want to see some information on classified information. Use the search engine to drill down on those results and get more content, more details on what we're looking for. The other things that really becomes interesting from this is that you can start building out really interesting search experiences over this. Now you're not limited to just search using traditional search and search results. Now we can start bringing in interesting visualizations. This is actually using a visualization technology called D3.js that allows us to leverage the data that comes back from Azure Search to visualize correlations. So you can see here that there is Oswald at the center, and we can see here it links to Jack Ruby, et cetera, down here. There's also an interesting thing down here. Just by looking at the correlations, you can see that there's a strong correlation to a person called Sylvia Durant. And this happens to be one of the informants to Oswald, according to this research. You would not have known that unless you looked at that content, you understood it, and built out the search experience over it. So those are some of the things that you can do once you tie artificial intelligence into the ingestion along with search. So now that we've seen a demonstration of this, why don't we dig into it and see how you actually go about implementing this type of thing. Excuse me, I'm just going to grab a drink of water. So there's a question here. It says, do you detect text also? How does your OCR work? Any new language support coming? So yeah, we absolutely can detect the text, as you saw in the demonstration we just showed. The OCR can detect the language and then actually bring back information as to what language was detected, and then we can actually use that to extract the text according to that language. And there are absolutely a number of different new languages support coming. I won't go through all of them now. I highly recommend if you take a look at the Azure Cognitive Service documentation under the Vision API, you can get a lot more information on the languages supported within that. So let me switch over to my portal here, and let me just refresh it here. So what I want to do now is show you how we leverage the Azure Search technology to build out a type of a solution like we were just looking at. While this is loading, I'm actually going to go over to my blob storage, and I want to show you a couple of things. So what I want to do is I have a number of different pieces of unstructured content, files stored within an Azure Blob Storage account. And hopefully you can see this. We have a number of images, PNG files, JPEG files. We have random PDF and Word documents. And these are a couple of the pieces of content that we're going to be able to look into. So, sorry, I should have just zoom it, but I'll show this in more detail in a second. What I'm going to do is I'm actually going to walk through the process of ingesting this. The first thing that I did, which I did before this demonstration started, was I created what's called an Azure Search Service. And if you've never done that, you can simply just go to create a resource within the portal. You can type in Azure Search and walk through the process. And in fact, we even have a free version. So if you just want to give this a try, everything I'm showing you right now, you can just do using a free service, and then we go up to paid services that give you dedicated capacity. But this is a search service that I had previously created. You'll notice this is running in our South Central region. What I want to do is create what's called an Azure Search Index. This is like a SQL table or something. It's the thing that you perform your full text searches against. So I need to ingest the data, all of the text, all the metadata from these files and bring them into the search index so that I can start performing the full text search queries that would power that web application, such as the JFK demo we just saw earlier. So I'm going to walk through how to do that. What I'm going to do is I'm going to click on this import data option right here. And this walks me through a process to start ingesting content. Now keep in mind there's two different ways you can get data into Azure Search. You can either push content programmatically or can use this indexer, which is like a crawler that connects to common data stores such as Blob Storage or Azure SQL or Cosmos DB and crawls it and ingests that content. Now, I'm actually going to just use an existing data source here that I configured. It just allows me to connect to that Blob Storage account. If I didn't have that, all I do is I simply choose Azure Blob Storage here and walk through this. So I'm going to choose this one right here. And next, I'm going to add in the cognitive search capabilities. All of those capabilities that we just saw, whether it's OCR or text analytics, so that we can actually look at the content, extract meaning from it, put structure to it, and put that into the index. So I'm just going to call this, let's just call this test for now. And what I'm going to do is I'm going to tell the Azure Search Index what we can do. So what I'm going to do is I'm going to choose Enable OCR here. And in fact, I think I might want to zoom this in a bit so you can hopefully just see this. Let's zoom in here. Zoom just a little bit more. Hopefully that's better. Hopefully that's good. So what we can see here is we chose what's called a skill set. So this is a set of skills that is going to be used during this ingestion phase. I'm going to tell it, I want you to do OCR. So if this is an image, I want you to extract out any text you find from in that. I'm going to go down a little bit further down here and say, what other cognitive skills do you want me to do? I'm actually just going to select them all. So you can see here, out of the box, some of the things that we can do are extracting people. So people's names that we found, organization names, locations, key phrases, as we said before. We can even identify celebrities. So we can identify if it's an interesting celebrity, put that into a field so that then that becomes easily searchable. So let's click on next here and walk on to the next step. And what this is doing is it's going to the Blob Storage, it's looking at those files, understanding if we can actually do those things that we asked about. And then what I'm going to do is I'm going to give, let's just call it test index. And these are all the different fields that are going to be created. Not only are we going to extract the content, but we're going to get a lot of other information, metadata, such as the file name, the file size, the file type. We can get information such as the people. This is a collection. So a whole set of people that potentially are found in that document are stored in this. Now, once we have all those fields, we can say, Azure Search, what do you want to be able to do with those fields? And we can say, first, I want to let my users retrieve those fields so that when they search, they can actually see the results. I can do some filtering. So for example, let's say that I want to make it so that I want to filter it where a document only includes Satya, our CEO, or Scott Guthrie, as we just saw in the image earlier before. We can also do what's called faceting, you can see here. And faceting is the idea of grouping content. So you might have seen this if you've ever gone to a retail store, where if you search for something such as shoes, a facet might be the manufacturer with all the different manufacturers that you can then drill into. It could be the price, it could be the size, it could be a number of other different factors. But what a search engine is really good at is being able to look at that content, drill into it, and then allow you to facet or group it so you can drill into those results. Keep in mind, if we didn't have that structure, if we didn't extract that metadata, you would never have been able to do that. Now, another thing, just to kind of finish off, you can also say whether that field is full text searchable. If it is the content, that probably makes sense to be full text searchable. If it's the file size, maybe that doesn't make sense, but maybe it does make sense to make that sortable, etc. And so we can just kind of configure this. Keep in mind, I already have an index that already has the content ingested that we'll look at in a minute. But hopefully this gives you an idea of how to link that enriched content to an index. The final step is to create what's called the indexer. This is the crawler. This is the thing that says, and I'm just going to give it a name here, this is the thing that says how often do you want Azure Search to check your store for new data, new content that needs to be crawled and ingested. I'm just going to click on once because I am just using this as a demonstration. There's a lot of other advanced options you can choose here, but I'm just going to click on submit to get this going. So at this point, keep in mind, I have not done a single bit of coding. All that I did was I configured the Azure Search Index so that I can actually start getting that content ingested, enriched using the cognitive services built in, and then allowing me to build out a search experience over it. So while that's running, I'm actually going to go to an index that I had previously created, and I had actually configured the schema for it. And you can see here, if we look at it, it's already ingesting some of the content into test, but we're going to go to this one called Blob Demo. And as you can see, it has a very similar set of fields and schema associated with it. But what I want to do is actually start doing some searches against it. But before I do that, let me give you a little bit more closer of a look at what some of that content looks like. So let's start with one of these files right here. This is just a PDF that was ingested. It was sitting in the blob storage. We brought it in and we started doing the enrichment. But if you look at it, it's actually kind of complicated because not only is there some text, such as here, but there are some images in there that maybe have some interesting text, such as locations. If we go down a little bit further, there's a lot more information. It's just a combination of text and images that come into play here. So let's just take a look at here and see if we can find that document. Now, I know that in this document, it refers to Chicago within an image. So let's just see if we can do a full text search on that and bring it up. So I'm going to use the Search Explorer, and I'm going to put in the word Chicago and see if we can find that, see that document. And we can see here, was this the right document? Let me go down here and just make sure. You can see there's an awful lot of text in here. Oh, no, this is a different one. Let me pick a word that's probably a little bit more unique. Let's choose Dallas. I'm pretty sure that one's probably unique. So we'll search for the word Dallas. And here we have the document. Actually, this was the right one. And we can see here is the text that we extracted. If we go back over to the PDF, you'll notice here's that exact text that we extracted from there. And there's just a lot more that becomes full text searchable, just huge. So what I'm going to do, and I'm going to say, you know what, Azure Search, I don't want you to bring back all the data. I just want to get a couple of fields. So I'm going to say, and select equals locations. I'm just going to bring back the locations field. $select, sorry. There we go. So you notice here, I did the full text search for that word Dallas. It brought back for this particular document all of the locations that were found within that. The only way that we were able to do that is by taking this PDF, extracting this image from it, doing OCR on it so that we can actually get the words in it, and then using text analytics, as we mentioned, to identify the locations within it. So there were actually multiple things that we needed to do to get that level of detail. Now, this becomes easily facettable. So I can actually see, oh my gosh, I keep going to the wrong tab. If we see in the results here, we can actually get all of the different locations listed in there, thanks to the power of cognitive services. Let me show you another example here. I'm going to go into this, this document here. This is a, just a stockholders letter. It's, once again, it's a PDF. There's a couple of interesting things in here, a lot of different information from this. But I'm going to say, okay, let me just copy the text so I don't have to type it all. And I'll show you a couple other capabilities of Azure Search. I'm going to paste in this. And what I'm going to do is I'm going to say Azure Search. I'm not going to actually do a full text search. What I'm going to do is I'm going to tell Azure Search I know the specific name of that file. So I want you to actually limit the results to where this field name equals this file. So I'm going to actually just get that content in there. But if you'll notice here, there's a lot of information. So if you're doing financial reporting, wouldn't it be great to be able to say, okay, show me all the financial documents that talk about this organization? Well, all I need to do is say, okay, and facet and, over the organizations. And we can see here are all the different organizations that were mentioned within that. And then I can then use the filter capability to say, okay, search for this document, but filter where the organization talks about AOCI or whatever happens to be in there. I could say, okay, show me all of the people that were listed in there. And you can see here's a number of different people that were identified within that document. So this, regardless of whether you're using this for financial documents, medical documents, or just other business level documents, being able to enrich that content with important information becomes very, very powerful. I'm going to show a couple other examples just because I find this really interesting. This is a picture of Scott Guthrie, Executive Vice President that we mentioned before. And we want to see, okay, what can we see from this image? You know, as we saw before, just being able to identify it's Scott is great. But what else can we find in here that might be interesting? So what we did is, as this was one of those files that we ingested, so I'm going to go back to the search and see what we can find. So I'm going to first say, okay, I'm just going to search for the word Guthrie, see if we can find that document. And here it is. It's guthrie.jpg, which is the image that we looked at. And I'm going to go down a little bit more and we can see what we found. First of all, we identified the organization as Microsoft. And you might ask, how did we know that? Well, I don't know if you noticed, but in the background there, it actually has the word Microsoft. So the OCR technology detected that as a word and brought it back into that. So that now becomes, you know, if I wanted to search for words like Microsoft, we can get that. If we look at key phrases, we have that here. We can go down a little bit more. We noticed here that, if I can scroll down here, actually let me just, there we go. We have the celebrity detection. It actually identified Scott Guthrie is defined as a celebrity, which is kind of exciting. So we were able to do this. You know, you would assume that in many cases this would be, you know, movie stars, very famous people in there, which we had the ability to do. But it did detect Scott Guthrie. So that was pretty cool. And I was trying to think, okay, well, how far does this go? You know, what's the definition of a celebrity? So of course, I thought, you know, what I want to do is find out, am I a celebrity? Am I going to be defined as a celebrity? This is actually a picture I took of my son. We were in Switzerland, and you know, I think it's kind of a nice picture. It has a picture of the mountains in the background, and I thought, you know, why don't I ingest this and see what we get from the results? And so I brought that back, and I'm going to do a search for this specific document. And I know, hopefully from the object detection, hopefully it'll detect that there's a mountain. So let me just type in mountain and see if it finds it, which it does. Here's that image we were just looking at. And we go down a little bit further. Unfortunately, I am not considered a celebrity yet. So it did not identify me or put me into that picture. But as time goes on and gets better trained, hopefully I'll get in there. It did not. But when I looked at the results, there were a couple of things that were kind of interesting. For example, I first looked at this and it said Levi's. And I was like, well, that was weird. I assumed that was somewhat of a mistake. But in fact, if you go back to the image, you'll notice here in this image, my son does have a shirt, it says Levi's, but if I zoom in on this, you can actually see it did a great job because it identified, even though a good portion of the L was removed from view, it still detected that as a word that we can do. So it can even identify these odd mistakes or these partial words from this. Some of the other things that are kind of cool from this are, if we look at the, sorry, I'm moving really quickly through this. Oh, here we go. So you'll notice a bunch of interesting words: mountain, outdoor, person, grass, man, stand, posting. There's a lot of interesting things. It even identified snow. The woman, that one's, I'm not sure about that one, but it identified a couple of really key words that helped me understand the objects within that image that allow me to then filter down on those results. So hopefully we're starting to see now how you can start integrating all of the knowledge capabilities, all of the capabilities from cognitive services directly into Azure Search so that we can actually start building out this type of a search experience. So let me switch back to the PowerPoint for a minute, and I want to show you a couple of other things. Just move a little bit down. And I'm going to start up this. So all of the things that we just showed you are part of a scenario we call cognitive search. And it's important to note that cognitive search is a part of Azure Search. It is the ability to leverage those artificial intelligence capabilities during the ingestion to understand it, to allow you to build out a new search experience. So in mind, this is all part of Azure Search. And if we look at it at the very highest level, there are three main parts to this process. There is the ingestion. There is the ability to bring in that content. There is the enrichment of that. And then the exploration over Azure Search. If we look at a more extensive slide here, you can see that what we can do is we take your data. Keep in mind when we set up your indexer, we pointed it at your data. We did what's called document cracking. We looked at that content, extracted text from it, because the text is the core piece of information that we need to then start building out the enrichment over that. And if we look at this in a little bit more detail, we have a huge number of different stores that you can connect to. We have a huge number of different file types that we can understand and extract meaning from, extract text from. So this is the process of document cracking. You don't need to worry about the different formats. You can just point it at those files. We will ingest them, extract the text from it, so that we can then do further processing over it. The second step is this part of enrichment. Once we've cracked it, we have the underlying text, then we need to apply the cognitive services to it. And as you can see, and I actually walked through a huge number of different examples here, we have so many built-in skills. As you saw in the portal, you simply just put a check mark beside the types of skills that you want us to process. So if you don't have images and you don't want to do OCR, you don't need to select that. You can just choose the ones that are viable for you. But it's important to note that not every customer is going to have the exact same type of content. So for example, some of those skills that we have built in here are not enough. If you go to a medical data set, you might find, well, that's great that you can do people and organizations, and I'll use that. But I'm also really interested in things such as medications, diseases, medical mentions, other aspects of your content, other entity types. So what you can do is, even in those cases where we do not have a built-in skill, you can simply choose to use your own skills that you've built, or some of the ones that are that are available either from open source or other technologies. And in fact, in a few minutes, I'm actually going to show you an example of how we did that for the medical industry. So you can plug in your own custom skills, your own custom machine learning models that you've built into this process. Leverage what we have built in, but enhance it as needed. Then, as you can see here, here's just what we have, what's called a skill set. When you walk through the process, you can build up these skills based on what's important to you. So for example, remember when we looked at that PDF that identified the cities such as Dallas? Well, what we did is we actually added in multiple levels of skills. We did the OCR so that we extracted any text from that. We merged all of that text from the OCR with the underlying text in the PDF. We then ran a number of different skills such as the organization, entity recognition, and we also did location. So remember when we were able to see Dallas and Houston and Toronto and other locations, that was because we combined multiple skills one after another to actually keep building on it to get the level of detail that we want. Now you might want to even go deeper, but the nice part about a skill set is that you can enhance these and build these on based on whatever you might need to do. I'll just keep going on here. And then the final part here is what we saw from the indexer. Once you actually have your content in there, then you can start doing those full text searches over that content. You can start doing interesting things such as limiting results based on locations, etc. Now, actually, before I switch back to that, what I wanted to do is I want to go through another demonstration. And this is much more extensive. So if you recall back on the JFK demo, one of the things that you saw from here is the set of tags. Those were the key phrases. But it's important to note from this that these are not categorized. You know, it's one thing to be able to search for key phrases, but often I want to categorize it. You know, I don't want to see all the words. I want to say, you know, very different categories like people, organizations, or locations. So what I'm going to show you is a more comprehensive demo that we built. And this is using a medical data set. It's called PubMed. PubMed provides a number of different medical journals. There's something like 1.9 million medical journals that have been made available to us. Now, for those of you that know this content, you'll know that they actually did a really good job of putting some structure to it. But we thought it would be interesting to say, okay, let's not use that structure. Let's just see what we can do from that content, bring it in, enrich it, and then start putting meaning to it. So what I'm going to do is I'm going to choose a disease. I'm going to choose a rare disease, which is called Morquio. And you'll see in a second why I'm choosing it. You notice here how we have that type head, so it can actually suggest potential terms from here. But I chose this disease because it is rare. It doesn't happen, it's not found in a lot of documents. I think it's something like low tens numbers of documents across all 1.9 million. So I thought that would be an interesting one because even getting meaning from a smaller set of content is important to do. You know, I could be looking at a more well-known disease such as diabetes or cancer, and there's going to be a lot of content in there, a lot of things that we can learn from, but being able to drill down to a very specific disease, I think shows the power of this. And so if we look at this content now, one of the things that you'll see is on this left-hand side here, we actually have very categorized set of content. So if we look at here, we have information on the skeletal system, or the parts of the anatomy. We can see parts of factors that relate from a disease and disorder perspective, medical mentions, signs and symptoms, etc. And so for those of you that are not aware of this, this is a disease. It affects the skeletal system. You know, it's a rare disease, you know, often because of the skeletal curvature, it affects things such as neck, other things. And the other interesting thing is that there's actually some therapies being built on this, enzyme replacement therapies. So it's an interesting one to kind of look at in a little bit more detail. But you can imagine if you are doing research on this topic, being able to understand and drill down to it is very powerful. If I said, you know what, this is interesting, I do want to know how this affects the neck, I can then drill into this. Or I can say, you know what, I actually am very interested in this very specific type of morquio called mucopolysaccharidosis, which I can drill into it and really narrow down on the results. But over here on the search results, you notice a couple of interesting things. First of all, what you'll notice is that we did things such as hit highlighting, where as you're searching for terms, it's able to find the result and show you snippets of text that are interesting to this. one of the powers of Azure Search is the ability to then provide what's called synonyms, so that you can actually tell us words that mean the same thing. So that it doesn't matter if you're searching for Morchio or other variations, maybe it's called MPS, we can understand that and tie those together and handle those variations. You'll also notice here that if we start looking at the graph, let's look at that and see what that looks like now. So just like in the JFK demo, where we were looking at the Oswald example and seeing correlations based on key phrases, now, because we have an even more detailed level of analysis, we can go in deeper and we can say, you know what, I can see here, obviously there's a lot of correlation to the skeletal system, as we would expect. If I wanted to drill into the things that relate to Morchio and the neck, we can see other information here, can further define that. Or maybe I'm interested, who are the people that have done a lot of research into this fact? And we can see here that there are a lot of different doctors. For example, there's or people. This one happens to be a doctor. I was noticing he does a enzyme replacement therapy. So he is very knowledgeable of this. But you can see all the different correlations from different aspects from the search engine. This all happened because we looked at that content, we received meaning from it, and allowed us to drill into those results. So what I wanted to show you before we kind of move on is just some of the other factors in here. For those of you that are interested in this one for the particular medical aspect, what we did is we didn't have a specific medical skill. We didn't have the ability built into Azure Search to understand parts of the anatomy that were identified in the text. We didn't have other machine learning models to identify other pieces of items. So what we did is we leveraged an open source technology. This one happens to be called Apache CTAKES, Clinical Text and Knowledge Extraction. That was really powerful for this capability. So we could use the ingestion process that we have to do the analysis, extract the text, and then we can plug in custom skills. In this case, we leverage Apache CTAKES so that it could then do a further refinement of this and say, okay, here are the medications that were mentioned. Here are the parts of the anatomy that were mentioned. All of this is extra information that we can then review and start drilling into. So all of that can be plugged into this as a result. So what I wanted to kind of leave you with before we kind of close this off and open up for questions, I wanted to kind of show you a couple of resources so that if you wanted to learn a little bit more. First of all, and hopefully we'll be sharing these in the instant message for the users that cannot see this page, but this is a GitHub site. If you want to give the JFK demo a try, you can actually go to this link here. This is a GitHub site so that you can actually learn more. We actually have a couple of other resources here that you can leverage. We have this one. In fact, I'm just going to copy this and show you. And this one allows you to build out the medical demo that you just saw. So to ingest medical content, use the Apache CTAKE so that it can understand it during that process, do the search over it, and get the results. And then, of course, just a simple link here on Azure Search if you want to learn more. So that hopefully gives you some of the ideas of what you're going to be able to do. So before I kind of go on to some of the other technical aspects, I thought that maybe what I could do is see if there's any questions currently from people that are listening that I might be able to answer. And I can see actually there's a few. So there was a question here that says, is there any kind of data that works better for this or that I cannot ingest into search? That's a really good question because as you saw from that slide that we showed a little bit earlier, there are some very well-defined file types that we just work with out of the box. PDF, Office, HTML, images, etc. Those ones work great. You don't have to do anything to it. But in many cases, there are content types that may be proprietary to your industry. It may be not something that we work with out of the box. So that is where some of these custom skills become very powerful because You can support the file types that we just work on, but you can plug in a custom skill so that maybe it extracts the text from that file type, or maybe you're using something such as Apache Tika to do some additional processing of content and bring it in. Other times, if we look at cases such as video, you can imagine within a video, such as this one, there might be a lot of interesting things that could be used from a text perspective. Maybe if you transcribe that video and you're searching for the word Azure Search, or where I mentioned medical NER, things like the transcription can be very powerful. And that's where things such as plugging in our media indexer capabilities into this process allows you to get the more defined content. So great question. Yes, there are absolutely some that are out of the box, but it doesn't mean that you can't enhance this by adding in additional types if you want to do that. And obviously we're enhancing that more and more over time. So another question from David says, how much data is too much data to index and search? Any particular size limitations? Yeah, so let's go through that for a few minutes, because it is true. Azure Search, the way that it works is that you pay based on the usage. So you can scale an Azure Search service as you add in more content, which obviously is going to add more cost to it. We also have the ability to easily scale it based on the number of queries or the throughput. So if you have a large number of users searching, hundreds, thousands, you can scale it up to handle that load, and that's going to cost more as well. But let's specifically go into the question of how much is too big. And so right now in our current search service, it can scale up to 2.4 terabytes of Azure Search index space per service. That doesn't mean you can't span it over multiple search services, but within a single service, a single index, that is the limit. So if you think about it, when your regional content, it may be significantly larger. Because if you look at a PDF, once you extract the text from that, it becomes a fraction of that size. So please don't assume just because you have 24 terabytes or way more content that it's not going to work within the size limits of the Azure Search Index as of today. But I will also mention, and this is, I'll just kind of mention this now, is that we are actively working on new SKUs that will allow us to scale significantly larger than this. So even if your content is in the hundreds of terabytes or more, I would not cause that to make you think not to look at Azure Search. In fact, I would be very interested in talking to you more if this is an area where you do have a lot of content and start to look at some of the new SKUs that we're working on. My Twitter handle is LiamCA if you're interested. But that's a great question, because it is something that you need to think about, because the amount of content you have does impact the costs as well. So let's go through a couple other questions. So how good is your handwriting analysis? That's a great question, because handwriting can be very challenging. If we go back to that medical example, you can get some doctor's handwriting that is very challenging to do. What I will say, though, is that our OCR has gone through a significant improvement. We now, especially in things such as English, we use neural nets to really go through and build out these models to understand the content within it to be able to extract the text. So hard to say how effective it is. However, what I will say is that with the new enhancements that we've done over the last couple months, there has been a big leap in the ability to be able to do OCR and handwriting. So if you have not tried it in the last little while, first of all, I highly recommend you take a look at Kelly's video that we just went through earlier, but also give that a try. So let's talk about the next question. Can you search through audio files? Yeah, one of the great things that we saw or talked about just a few minutes ago was the ability to do transcription, so that you can then search for it. And so there's been some really great customer examples of this, where what people do is let's say it's a training video, and they want to say, okay, I want to search for these words, or maybe search for medical NER within this presentation I'm just looking at, but not only find the video, the audio or video that comes in there, but find that point in time. So that is also true for audio. you could do the same type of thing, the transcription over that content, so that you can then find that very specific point in time that those words were said within your audio and then start playing it. So there's all kinds of different capabilities to do that. But I will stress that transcription's not perfect. There's all kinds of different variations to words that can come in. So if you can think about a good example that I really like that I've found is that SQL. If somebody says the word SQL, often the transcription will come back not SQL, which is what most people might expect, but it might come back as SEQUEL, which sounds the same way, but it's not the same thing. And that's actually one of the reasons why a search engine like Azure Search can be really, really helpful. Because if you're searching for the word SQL and it was transcribed as SEQUEL, then it's not going to be a match, right? But because of Azure Search's abilities to allow you to do deep level of customization, you can do things such as build a custom analyzer, where what it does is when that query comes in, you can say, you know what, if you find the word SQL, that's great. But if you find a match that is, say, phonetically similar, sounds similar, then bring that back as a result, but don't give it the same level of ranking. And that's really important to note, because in search indexes, it's one thing to find matches, but it's another thing to be able to tune the results based on what's important to you. So you can actually build out all these types of ranking and weighting systems so that you can actually build out that type of thing. So Simone, to your question, if you are looking to do audio, I absolutely think that this is a great example. However, keep in mind some of those advanced capabilities of Azure Search, such as custom analyzers, to really dig into and refine the types of results that you might be getting back from the results. Let's see. So what data store should I use? Cosmos DB, Blob Storage, SQL. What about non-Azure storage? Can I import from other clouds? Yeah, definitely there's a lot of different choices there. It's hard to say which of those. Well, let me start with the Cosmos DB, Blob Storage, and SQL first, because each of them have their advantages to it. So a lot of this comes down to what you're looking to do with those stores. So for each of those stores, Azure Search works equally well. We have crawlers for each of those stores, so you can point to it, we can crawl it, ingest your content, and make it searchable. So from that aspect, I don't think that it makes a big difference. But there are definitely some characteristics of those stores that are important to you for other reasons. Maybe there's some things where you're looking to do analytics over your data. Maybe there's some data within there that you want to do something more with it. And maybe those stores are more optimized. You probably wouldn't use Blob Storage for that, whereas you might consider that for, say, Cosmos DB or SQL. So a lot of that comes down to those facts. Obviously, there is also a price difference from that as well. So if you are looking at just hosting the content so that we can crawl it, maybe Blob Storage is more efficient because it is a lower cost store. So from that perspective, I would look at it from those factors. Now the question is about non-Azure storage. So yeah, from our crawlers, we can ingest content from Azure stores. So if you happen to be in Azure, then it's very easy for us to bring it in. If you happen to have, say, a SQL that's publicly accessible, say it's running in a different cloud, as long as we can connect to it, we can ingest the content. But even in those cases where maybe it's sitting in a different cloud, maybe your data is in your own organization, then what you can do is you can programmatically push that content. You can say Azure Search, here's the content that I want you to bring in and ingest that and search that. And so with that, you can do a lot of work. In fact, just earlier today, we just announced containers for many of our cognitive services. So you can actually run, say, text analytics or the vision or the other things as containers within your own environment. You don't necessarily have to use those APIs. You can run them as containers so that in your organization, you can do that processing, get the information you need, and then push that into Azure Search. And in fact, we actually find that to be one of the nice steps first steps that customers take when they move into Azure is because they have these workloads that involve search that they would love to either move off their SQL or move off their existing environment. So they just simply move that workload up into Azure Search. And this is a great way of how you can leverage that. So hopefully that covers some of the topics you were interested in. How fast does the search index run? Can I add more processors power to improve performance? Can I run in multiple regions? Yeah, lots of questions there. So let's go through that. In fact, that we'll probably leave this as probably one of the last questions because we're starting to run low on time. But yeah, so how fast does it run? Some of that is hard to answer because as you can imagine, if you go against a store such as SQL or Cosmos DB, you can create these queries that are either very simple, like a lookup, an index lookup, or a really complicated query that has multiple filters and very, very challenging. So the amount of time that we're going to take to complete that is going to vary. But typically what you're going to find is we aim for like the millisecond response time. The other thing you'll notice in Azure Search is that you can choose a SKU. So each SKU gives you more and more power. So it is backed by faster processors, more memory, etc. So it can allow you to perform queries quite fast and even be able to handle large numbers of users. We have customers that do high hundreds, if not thousands, of searches every single second. So being able to perform that at a low millisecond response rate is very, very important. So can you add more processors? It's not like you say Azure Search give more processors, but you can absolutely say I want to use a higher SKU, a higher tier that has more processors, more performance, and you can also scale up. So if you're finding that you have maybe tens of users searching now, but all of a sudden you're hundreds or thousands, you can scale up that workload to be able to perform more searches. So it's very easy to move up and down. And I feel that's actually one of the strengths of Azure Search, is the fact that you can easily manage that and scale it up and scale down based on what's important to you. And finally, to that last question, yes, we are in all of the geographies that you will find Azure across the world. And so you can spin up Azure Search in multiple regions using things such as Azure Traffic Manager are great because if a user is coming in from somewhere in Asia, maybe you direct them to the search service in an Asian region, similar for Europe and for US. So that allows you to have a deep level of control from that perspective. And I actually got through that quicker than I thought, so I am going to give one more question, and it's about, what about PII? Can I use cognitive search to find it and pull it out, or even black it out? Yeah, that's great. One of the things I didn't show in that JFK demo was the idea of doing things such as redaction. So it actually identified if content was redacted in that content. So you can actually refine into that. So you can definitely use it for those capabilities. Now, do we have a built-in skill that detects PII information or actually blacking out your content? No, but that's okay, because in the cases of blacking it out, one of the things that we do is we give you bounding boxes. So this word was said in this region of the image, and then what you can do is through your application, you can black it out yourself. So do we have that built in? No, but it's very easy to build that in and customize it for you. So thank you so much for the great questions. Looks like I'm running low on time right now. So what I'm going to do is I am going to close this. I'm going to bring up this slide for anyone that didn't get to see it. So it has a couple of resources for you to learn a little bit more. I'd love to hear from you. If you're interested in talking more about Azure Search, my Twitter handle is liamca, Liamca. But once again, thank you so much for your time, and I hope that you'll stay on for some of the other sessions we have today. Thank you so much, and we'll talk soon.